Hello, hello, hello. Good morning. Woo! Woo! What is it? It's today. Today's Friday. Friday. Ow! Is that too much energy for you? Were you drinking too much last night? Woo! All right. So first up this morning is Sandi Metz, and she's going to talk to us about all the little things. And I want to relay a little story about when I met Sandi. Yeah, that was the only pun I could come up with for her. Anyway, no, really, I want to tell a little story about the first time I met her. It was I think the first place we met was RubyConf. I can't remember. It was in 2007, I want to say. It was 2006 or 2007. I met her first. And she came up to me, and at the time I was the maintainer of the mechanized gem, and she came up to me and said, "Aaron, you're the maintainer of the mechanized gem. I use your code all the time." And I was like, "Oh, me? You know who I am?" And so it was that was the very first time that anybody ever recognized me for any open source stuff that I did. So that's always stuck with me, and it was an awesome memory of Sandi. So with that, I'm going to turn the stage over to her, so everybody welcome Sandi.
It's very sweet. Good morning. What a beautiful day out there. Is this amazing? Don't y'all want to move to Bend? Everybody who doesn't live here. All right. And actually, how many people were here for Mark's talk yesterday? So you're well prepared for mine. It turns out, it's all the same thing. We talk about the same things over and over again. We just say them in different ways. And so that was nice. You've had a preview of this. Except I told some people yesterday that my talk was just like Mark's, except it was, with transitions, 369 slides, and I'm going to do it at 78 instead of 33 RPM. So wake up. We're going. All right. So you would think that object-oriented programming is hard. I mean, all you have to do is look at our code, right? We write these messes that we can't change or maintain. We mean well, but we just create chaos. And the more I think about this, the more I believe that all the problems we create can be solved by one simple thing. And now, these days, I'm in a position where people sometimes ask me for advice about how to write code. And I've reduced all of the advice I could give people to one thing. Make smaller things. Write little objects. Make little methods. And make them know a little about each other as possible. And so lately, I've been on a quest. I've had this obsession with the thought of conditionals. And I went to RubyConf in November in Miami, and I inflicted this obsession upon Jim Weirich. And he listened to me very patiently and kindly, like he does. And I had a problem I gave him, and he gave me a problem in return. He shared a problem with me, and it was the gilded rose kata. Now, some of you may know this kata, but I don't get out much. So, of course, I had never heard of it. And it was, so I went and looked at the code. He has a repo on GitHub that's got the kata in it. And I went and looked at the code, and it just annoyed me. It was a mess. And it bothered me, but I didn't touch it, and then I couldn't let it go, and I finally went back around Christmas time and started doing some refactorings of it. And then early in the new year, when I was thinking about this talk, I realized that the code of the Gilded Rose Kata would be a perfect skeleton upon which to hang the ideas for this talk. And so this entire talk is going to be code. You're done with pictures. Well, there's one more picture. Now we're going to look at code for 30 minutes. And usually, I get easily distracted, and so I try to make talks that have a beginning and a middle and an end, where you know what part I'm in. But today's talk's a little different, because I just was lost the whole time I was working on this. And so you're going to parallel my journey. This is my journey through the Gilded Rose. I changed his code a little bit to make it easier to talk about, but fundamentally the problem is the same. So if you look at his repo, it looks a little different, but really it's this. And so here's what we have. We have this Gilded Rose class that has these three attributes: name, quality, days remaining. There's an initializer form, and then it has this tick method. And the tick method looks like this. Well, half of it does. And here's the other half. Now, I didn't realize I was going to be in this wonderful space where you could probably see, but you're not intended to be able to read that code. That's the whole tick method, and it's to give you a sense of the shape of it. I am well known among people who pair with me as being Boolean impaired. And so my sense that this was complicated, my sense was that this was very complicated, but I wanted an empirical measure of complexity, and so I ran flog against it. And so that class flogged to 50, and the tick method flogged to 45. And so flog agrees with me that this code is complicated, but before we go on, I want to introduce another metric. These days, I spend a fair amount of time looking at other people's code. People call me up. They ask me to come by for a few days, spend some time working with them. You too could do this. I suck at self-promotion, but I thought I would stick that in. So as you might imagine, when people call me, it is not because things are going well. They call me because they have, and when they call me because they have a mess. And when I get there, they don't ask me to look at the nice parts of their code, right? They want me to look at the most horrible bit. And so they show me, so here's what happens, right? They show me some heinous bit of code, and they start explaining it to me. And like all of us, you know this feeling like you have some really crappy code that you hate, you're really embarrassed about? So when you're trying to explain it to somebody, you don't just tell them how it works, you tell them all the terrible things that happen that cause you to write it that way. Right? There's a lot of explaining that's not about domain. And so there's some point, so there's a lot of talk when I go in and I'm looking at some piece of code. And despite, I mean well, I really do. I mean well, but there is some point during every explanation where I start to feel like that dog Ginger in the Gary Larson cartoon, what people say. So here's what happens. It's like blah, 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 Sandi, blah, 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 Sandi, blah, blah. And then suddenly I'm like startled back into awareness because they say, and what do you think we should do about this line of code? And I'm like, ah. And so for a while, this terrified me. And absolutely, like I feared that I would go places and they would spend money to get me there and I would be unable to help them. But it turned out it's really easy to help. It's really easy to look at code like this and tell what part you could usefully change. And I developed a new metric for this. It's called the squint test. Here's how it works. You squint your eyes, and you lean back, and you look at the code. And we're looking for changes in shape and changes in color. Changes in shape mean that you have nested conditionals, and it's going to be hard to reason about. Changes in color means that your code is not all at the same level of abstraction, and the story that it tells is going to be confusing. And so, what's wrong with this code? Well, it has 16 if statements. 7 of them use not equal. 2 of those are connected with and. There are 3 magic strings that are used repeatedly and a bunch of magic numbers, too many really to count. The magic strings are these 3 things, and they seem to, all the conditional logic seems to start with them. It's as if there's a concept here that they represent that has not been identified. Now, it does have tests. Thank God, it has tests. And all the tests passed, there are 6 tests that are skipped. And so we're going to get back to the skip tests in a minute. So the tests all seem to cluster around the magic strings, except there's a set of tests that are around for normal, which is never referenced in the code, never referenced in that if statement. And so let's have a look at one test. I'm going to pry one test open. And so they all look kind of like this. There's something, some item, and then some talk of selling. And then I'm given a gilded rose item. It takes 3 arguments. It's name, quality, and days remaining. And then when I do a tick, something happens. In this case, quality goes to 9, and days remaining goes to 4, so they get reduced by 1. And so now I'm starting to get the sense, the gilded rose is well known. Like, if you Google it, it'll explain what's going on. But I didn't do that. I wanted to treat this as if it were a real production problem. Because even though they wrote this if statement to torture people, intentionally, right? This is an Akata, so it's meant to be hard. But there's plenty of production code that looks just like this that people did by accident, right? So I'm treating this as if the only information I can get is from the code I have. And so now I finally get it, right? These are the 6 skip tests. They're for something called conjure. And at this point I realize I understand what's going on. And I'm going to quote Aaron. holy crap, I'm supposed to change this code. There's 6 tests, and I'm supposed to implement them. And so all the tests have the same form, so they all look just like that. Like, given a new Gilded Rose item, when I tick it, something happens to quantity and days remaining. And so I went and I tried. I tried to make those tests pass. So I tried really hard. And even, I am Boolean impaired, but that did not deter me. I tried really hard, but I failed miserably. I could not do it. I spent hours trying to make these tests pass by changing that if statement. Every time I could get one piece of one of these working, I would break some test that was already running green. I mean, I found that you would probably find it easier than I, but you might be able to do it, but I found it impossible. And so, if it's so hard, if it's impossible to change that if statement, and I'm supposed to be, all oop, then you have to wonder why I even tried. Like, what made me go try to choose as my strategy changing that if statement? Well, it's because I felt like I was supposed to do it. I felt like I was supposed to. And here's what happens. Someone writes some code, and then someone else gets asked to change that code. Or that someone gets asked to do a new thing that's kind of related to code that's already written. And what they do is they go look in your code base for some code that's like what they're trying to do. Maybe the first person that wrote it put an if statement in it. And if statements are like, they exert gravitational pull, right? So I have a new thing to do. It's kind of like an old thing. Maybe I'm a novice, and novices feel like they are not allowed to make new classes. And so what happens is code gets bigger. That's its natural tendency. But then unfortunately, there's a point where code gets big enough so that it tips. And it feels like, even if you're the kind of person who would normally make a new class, that you would be doing the past and the future a disservice by putting code anywhere else. When you believe that people expect to find things there, when you have a 5,000-line subclass of active record, you do not make a 20-line service object that goes with it when you have a new requirement. You feel like you have to put the code where it is. And so I was failed by the pattern failed me. That if statement felt like it had evolved evolutionarily, and that any change I made, I was supposed to make there. But fortunately, I couldn't do it. And so I decided I would make a new pattern. I'm going to refactor the code. I'm going to rearrange the code without changing its behavior. I'm going to make it so that I'm going to simplify this code so that I can add conjured. And since I'm doing a refactoring, I have to have tests with a wall at my back. And so I'm just going to start at the top of the test suite and try to rewrite the code. And I know that I do not understand that frickin' if statement. And so if this were many small objects, when you have a lot of small objects and you send messages between them, what happens is the messages create a seam. Messages give you substitutability. You can put another object behind that message on the other side of the seam. And the problem with procedures, one of the reasons that procedures are so hard to change is that there are no seams. And so the first thing I have to do here if I want to write code without altering this statement is I have to create a seam. So I'm just going to catch normal and return. There are 4 tests for normal. I should have 4 broken tests at this point. And I do. So that's good news. So now I'm just going to call a method. I'm going to send a message to myself. And I still should have 4 broken tests. So now I feel confident that I can start trying to write code to make the normal test pass in this new place. And here's the first test. Looks like quality goes down by 1. Okay, I can do that. Days remaining goes down by 1. I can do that too. And now I just have 3 failures. And so I'm just going to follow this pattern. Here's the second test. In this case, I think it's like milk or cheese or eggs, right? It's counting down to when the sell-by date, and then stuff goes bad. And so if there's no days remaining, quality went down by 2. And so first I have to make sure the test I just wrote still continues to pass, so I'll wrap it in an if statement, and then I'll put days remaining. If I'm past the sell-by date, quality goes down by 2. All right, so now 2 tests ought to pass. 2 tests ought to fail, but of course only 1 does. So I accidentally wrote some code to make a test pass. I don't even know what I did, and I don't care. It absolutely does not matter. I'm not even going to go look and figure out what that test is, right? I'm going to go make this test pass. This is the only failing test I have. So in this one it says, if quality is already 0, it doesn't go down anymore. All right, so I'll just say, don't change quality unless it's, I don't know, whatever that says, right? I'm Boolean impaired. And so now all the tests pass. And so now I'm going to refactor under green. I'm going to refactor this little bit of code that I wrote that I can understand. Well, really, the truth is I can't understand it. Already, I cannot understand the code I just wrote. I mean, this is how this stuff happens, right? So I'm going to rewrite this code now that I have the test running green. It looks to me like I always subtract 1 from days remaining. Days remaining always goes down. All right, so I'm just going to do that first. It looks to me like I only change quality if it's not 0. So I'm going to guard that and just get out of here. Nothing else happens unless quality's not 0. And I love a good guarding clause. It really helps me understand what's going on. So I can get rid of that. And now I have this thing, and it looks like there's 2 different things here, but I'm suspicious that there's not. It feels like, to me, that it's not there's a case where quality goes down by 1 and there's another case where quality goes down by 2. It feels like quality always goes down by 1, and then there's a special case in which it goes down by another. That's what I think is going on here. And so I'm going to get rid of that. And so now I have a little story here. Right? If there aren't any, so subtract 1 from days remaining, don't do anything else if there's no qualities. Subtract 1 from the quality I have, and then if I'm past the sell by date, subtract another. And so I like that. This code comforts me. Like, even I can understand this code. And the tests are still green. So let's just do a quick reprise here. So I put a shim in, I made a seam, and I wrote some code at that seam. And now all of the code for normal is still in that 43-line if statement. It's all in there. It's somewhere. I mean, I don't know where it is. I couldn't begin to tell you. I can't find it. But it's not executing anymore because I'm trapping it and exiting before I get there. And so normal's done. And so let's just run through the other cases. These will be, now that you see the pattern, these will be much faster. So I'm going to have to turn that into a case statement because I got to check on Bree, and I'm going to make a Bree tick method, and then I'm going to make sure I caught that all the tests failed. I caught everything that should have failed, and then I'm going to fast forward that and show you the code I ended up having. Right? And so this, interestingly enough, this looks a lot like the normal method. They share the algorithm they share in common. And I had no idea that they were so alike until I until I backed up and reintroduced duplication. And now that I see that the algorithm is very similar, there's a temptation to want to dry this code out here. But I would tell you, do not do it. Like, other kinds of ticks are coming. We're about to have tons more information about what to do. This code is very simple. There is no reason. Like the 43-line if statement in real life, in real production apps, got that way because people were trying to find some abstraction, and they got it wrong. And basically what I did is I just unwound the abstraction and recreated the duplication. And what you're seeing here is the duplication is actually, here, wait, I have a slide for this. The duplication is far simpler than the wrong abstraction. We teach, the very first rule we tell new programmers is don't repeat yourself. We teach them dry. And I contend that we teach them this because it's the only thing they can understand. Right? You remember when you were like that, I was like that, right? You could, by God, you don't know anything, but by God, you can recognize duplication. But once you get here, like once you have a seat in this room, you understand duplication, and you're better off tolerating duplication and waiting for more information. When I talk to people about duplication, very often what they say is, I'm afraid that, it's in 2 different files, I'm afraid that it'll get updated and I won't see it, and one will get missed. And so fix that problem, right? I make a tag, like a to-do tag, I make a dupe tag. And I just keep a file of, I give an ID to every duplicate, so I'll put dupe 1 in 2 places, or dupe 6 in 2 places. And so I have confidence that I can find the other duplicate of a piece of code while I'm waiting for more information. It's not going to get lost. Like, if you're afraid it'll get lost, solve that problem. Don't reach too soon for the wrong abstraction. And so, moving on, so now I'm on sulfurous. And sulfurous had 3 tests. It's got 3 tests. So if I catch it, I ought to have 3 failures, but it turns out nothing fails. And so I looked at the test, and what happens is that nothing happens. There's some, I don't know, these are all memes that I don't know about because I'm a woman of a certain age. And so the hand of rag, whatever it is, like it never changes, dead, right? And so nothing ever changes. So the empty implementation is indeed correct for this. That's all that happens. All right, so we're done with that. And so backstage passes, they have this whole thing where, the closer you get to the day of the concert, the more expensive the backstage pass gets, but then it plummets to 0 the day after. And so this code's a little more complicated, but there you go. That's all there is to it. And so at this point, all the tests pass. And here's what the tick method looks like. It's got all my traps at the top. It's got all my new code at the bottom. And it's got this big heinous thing in the middle, which isn't being used anymore, so I can just delete it. And I never understood it. But it doesn't matter. We would prefer not to. And so the moral of this story is that small methods are simple. They are absolutely dirt simple. And if you want, let's do the squint test on the code we just wrote versus the way it started. We actually have fewer lines of code now. And you can see that the shape is flatter, and the colors are starting to cluster together. The original thing flogged to 50. This new code flogs to 40, and the most complicated method is backstage, which flogs to 12. It's not an opinion. It is my opinion that these things are better, but there's empirical evidence that this is simpler code. So this is great. This is so awesome. It's so much easier to understand. It's simple. Why don't people do it? Why don't we do it all the time? Well, part of it is that thing I said before, I think, right? There's already code that looks a certain way, and you feel like your job is to make more code like that. That's one thing. Another reason why people don't do this is that it's really scary to do if you don't have good tests. If you don't trust the tests, you have to write tests at this point before you can undertake the refactoring. But I think there's another reason why people don't do that. I'm just going to scale down this graph and show you. So this is how I started. Now, I ended up at 40. The total flog score is 50. But these are the flog scores of the intermediate steps in the refactoring. Right? And what happens is if you don't have faith in this, if you can't look far enough ahead to see that you're going to get to 40, all of these steps just feel like they're a waste of time, that are making things more complicated. And so learning something about, like having confidence at refactoring, having skills in refactoring and confidence that they'll lead you to small objects is necessary because it takes a leap of faith to go all the way up to this 84 before you can get to the 40. Things get worse always before they get better. And so now I'm going to circle back around to my original job. I've done the refactoring. I'm supposed to be implementing Conjured. And here's what I have. Really, I have this. And so should I now do that? Well, so the pattern still fails me. So I would like this code to be open, closed. Open for extension, closed for modification. I would like to be able to add new behavior without getting in these files and editing this code. And right now, the pattern makes me do that. The pattern makes me add code to the class I'm working on, and, well, the tests are already there, but I would have to add tests to the test file. I don't want to do that. I break something every time I open something and touch it. I do not want to mess with code that works. And so I'm going to do another refactoring here. And here's what I'm going to do. These things, when you see this pattern, a repeating prefix with a common suffix or vice versa, when you see this pattern, what you know is you have objects in there that are screaming to get out. And so here's a picture. Here, let's do that again. Every time I practice, I get that click wrong. What these things want to be classes, and this thing wants to be a method in those classes. And so what we ought to do is we ought to have a normal class that implements the tick method that Gilded Rose is holding on to an instance of. That's what we want to do here. And the way to do it is incredibly simple to write this code. Let's do it. So I have this normal tick method in Gilded Rose. I'm just going to call it tick. I'm going to give it a class. I have to put this in. I need this initialization stuff because it needs those variables. Up in the old tick method, I just have to get an instance of it and then forward the tick message to it. That's all there is to it. I've created a little object. Now, of course, it looks like this right now, right? So I have one, normal's an object, but all the rest of that stuff's still in there as methods. And so I had this explosion of complexity. Normal tick gets an instance of item and calls tick, but breetick is all here. And so that means this is part of my public API. And so I have to do this in the code. If I have an item, ask it. Otherwise, return the one I know. Right? If I have a days remaining, if I have an item, ask it about days remaining. Otherwise, return I know. And so this is again that intermediate complexity that you have in the process of refactoring towards simplicity. And so let's just do this for everyone. I'm just going to take it. I'll make a new class. I'll give a tick method. We'll throw that stuff down there. We'll fling in the initialization. This is total duplication, right? I just did this. I don't care. Just duplicate it. Just do it over and over again. It'll be clear once we're done with everything. And so call it. This is really interesting. Okay, so I have an empty method. This is the sum total of the sum total of code I have for sulfurs. And look what I have to do to follow my new pattern. I have to replace an empty method with 10 new lines of code. You can be forgiven for worrying that this is going to turn out badly, right? But it needs to be an object. Backstage, same thing, just make it tick, put it up there, call it. Okay, so now they're all objects. And it looks like this, right? Gilded Rose has access to all of them. And so here, I made these methods. I created these methods to begin with because there's too much code in here to put up in the case statement, right? They all had like a bunch of checks and returns and guarding clauses. But now that everything has been simplified, I'm just going to rewind on that decision and push this stuff back up there. So I'm going to put the implementation back up there and delete those methods. So we got all that. Now, earlier I said that duplication is more expensive than the wrong abstraction. And that's true. But now that I have simple code, I can see the abstraction that underlies this. And I can safely dry out the code. And so let me just push this down and put that up there. So here, I don't need that anymore. What I need is to get a new item, some kind of item. I need to initialize myself on an item. And how would I do that? Well, it's this, right? I need to get one of those things. And so that's the message I want to send. And so I need the name of the class to fill in there with question marks. And where is it? Well, it's right here. And so if I give that a name, I can just send that message to myself, and I'll get the right item. And then I don't need name anymore because that's gone. And so now I have this little case statement that given a string will return the class name that should be responsible for answering messages that are related to that string. And so I'm just going to, and now we don't even have to think about that anymore, right? I'm going to squish that class 4 down, and we'll move on. So item got reduced to this, and these things now get simple again too, right? Because Gilded Rose doesn't do that anymore. It always has an item. It doesn't do a return. So now I have this sort of pattern of delegation and these 4 new classes that I just created. And so from Gilded Rose's point of view, like we know that those are all class names, and we have a hard time sort of having our thoughts not be trapped by thinking of them. But really, as far as Gilded Rose is concerned, item is a role. So Gilded Rose doesn't really think about it this way. It thinks about it like that. This is something that it honors that interface. It responds to tick quality and days remaining. And you notice its implementation just does this. And so if you were foo and you had a Gilded Rose and you sent those messages, you would do this. And this is a code smell. This is it's called middleman. And if your whole class acts as a middleman, if your sole purpose in life is to delegate messages to others, your class may not justify its own existence. Now, it turns out Gilded Rose does do something else. It does more than this. It does this. If someone passes new to it, if someone sends a new message to it and passes a string of a name, it acts like a little factory that'll manufacture the right kind of item. And so let's just accept that it's a factory. Just accept it. In fact, I love this word, right? I know that some people came from Java and you had like horrible ceremony that made you want to cry. But factories are really simple. And so there's a lot of time in Ruby when it would be handy just to acknowledge that I know some things and I would like to ask somebody to give me back an object that would do the right thing based on what I told it. And so I'm just going to change the code to acknowledge to make this more factory-like. I'm going to turn that into a module. This broke the test, so this is a breaking change. I had to go do one global change and replace in the test here. So I'm gonna say 4. Some people implement new on modules, but I don't know. I just hate that. You can if you want, but I usually say 4 in this case, so I have to make that. I don't need to save. I'm not saving an item anymore. I'm returning an item. This is a module. It's not holding on to anything, so I can get rid of all that. And so since I don't have an item, then the whole middleman stuff just disappears. And now the code has been reduced to this. And so here's the picture of it. So you ask the factory, and it gives you back an item, right? I'm not holding on to an instance of the factory. And the item that I get back responds to that interface. And so now I'm just going to do a little bit of extraction. I'm going to deal with this duplication that is down here where we put this stuff over and over again. We did that, right, in every class. And that's kind of annoying. We sort of hate that. So I'm going to make a superclass, push that all up to the superclass, subclass that, rip that out, make everybody like that. Okay. So we had a conversation. There was a question about inheritance yesterday after Mark's talk, and I've done pretty much the same thing here, right, that he did yesterday. And I would tell you that despite the fact that people tell you never, ever, ever use inheritance is not evil. And I can tell you exactly, I will give you dispensation to use it in a very specific case, all right? And here's the case. The hierarchy is shallow and narrow, right? It is not deep and wide. The hierarchy is shallow and narrow. The subclasses use every bit of code that's in the superclass. And if you draw a mental image of your object graph, the little tiny cluster, this little hierarchical cluster is at the edge of the graph. Right? So I'm going to say that again. Right? Shallow, narrow. The subclasses use all of the superclass, and it's on a leaf node of your object hierarchy. If those conditions are all true for the thing that you're doing, it is hard to find another more intention-revealing way to write this code. When those things change, you should think about moving to composition. If it drifts, if your app changes so that it encompasses this and it moves more toward the middle, or if you find yourself putting a lot of behavior in the superclass that the subclasses aren't using, all those things are signs that you should refactor away from inheritance. But it's the right solution here, I think. And so even though inheritance is not evil, programmers sometimes are. And we use inheritance. We don't know, we're bad at inheritance. And so I think there's a problem with this inheritance hierarchy, and it's this. It's the item has this API, quality and days remaining, and all the subclasses share that, but they have this one. They also implement tick. And I feel like, it's not a Liskov violation, I don't think, but it just bothers me. I think item ought to be able to tick. It feels to me like it should. And now the question becomes, what implementation of tick is correct? What is the correct implementation of tick up an item? And I think we have two choices here. One is you can implement tick and raise an error that says subclasses have to implement this. Right? There's a Ruby no method error or something for that. I still talk small talk, right? Subclass must implement that. So you could do that, right? But I think there's a default implementation of tick that makes sense here, and it's this. By default, tick does nothing. It's perfectly valid. Right? And once I get here, right, once the API drives me into implementing that method here, I'm just going to remove some code here so we can look at this. So now it's obvious that sulfurous overrides, subclasses item and overrides tick to do the same thing the superclass does. And what that means is all that complexity I added when I created that class, it would be equally correct for it just to get item here. And all that complexity I added when I replaced the empty method with 10 lines of code can just go away. And I didn't know it till I followed the refactoring to the end and fixed everything that bothered me. And so now we're left with this. This is the last bit. This looks like business logic, but it's really not. It's configuration. It's a key-value mapping pair between strings in the class that should answer them. And it's going to change at a different rate than all the other code in this class. It's not the same thing. And this makes it look like business logic, but it's not. I want to extract this configuration thing into a thing that looks more configuration-like. So I'm just going to stick that up there. Now, in real life, I would probably inject this. In real life, though, I would have done a bunch of things different here, but I followed as much of the pattern as I could of the code that I got. And you can look at this, and you can feel it moving toward being a YAML file or being something in a database, so that you can add or change this list without editing this code. And so now I have small objects. And here's all the code that we just wrote. There's the item. It's all inside the Gilded Rose module. There's item superclass, normal, Brie, and backstage. Subclass that, there's the configuration stuff, and I have this tiny little for factory method. The whole thing looks like this. Compared to the initial big conditional, it looks like that. And this is it compared to the small method implementation. You can see that the small objects implementation is a little bit longer, but also that the colors cluster more tightly together. This is a good thing. It flogs. Anybody want to guess? Actually, here, let me ask you: Does it have a higher flog score or a lower flog score? Yeah, it sure does. All right, and here's the intermediate steps. Right? It's no wonder people don't do this. You have to trust the refactorings to take you there. We're looking for small things, and they will be cheaper. This, however, I think this overstates the complexity of the final solution, because really that first thing, that was one class, and the second one was one class. But this solution we just wrote is many different objects, and you don't have to reason about all of them at once. That's the whole point, right? I can just forget about those other objects because I just trust them to work and they do the right thing. And so really what I'm dealing with here, the most complex object in there is backstage, which flogs to 12. And the average complexity of the set of objects we just created is 7. That's the average flog score of the objects that we just made. And so I contend to you that complexity just went down by 75%. And so now my task, again, as always, is to implement conjure. And so here's how it goes. That makes the test pass. And that makes it work. And that's it. That's all we got. And so you're all grown up, right? I mean, it is important not to repeat yourself, but you're allowed to wait for more information, and I urge you in many cases to do so. Very often, like I go a lot of places where they have really complicated code, and people try to detangle the messes by moving forward, and that can be very difficult. It's like me trying to change that 43-line if statement by moving forward. Very often, if you have things that seem overly complex, the best thing to do is rip all the modules out, like duplicate the module code everywhere you have, like put all the duplication back in and look at it. It's incredibly simple and very easy to do. You'll find that it's a much better strategy. In our case here, the individual tick methods were a lot alike, but we couldn't even see it. Like maybe there's more refactoring that we could do. We'd certainly take the if statements out of all those tick statements if we wanted to, but I don't really care. It's good enough right now. Like it feels very simple to me, easy to manage. Next, don't try to guess the future. Don't write code. Just write code that can adapt to it when it gets here. And that means that when a new requirement arrives, it was the conjures requirement that caused me to do this refactoring. And when I can't make a change, when a change request comes in and I can't make it without editing the code, then I do a refactoring to try to make it open close to the new request. That's the point in time when I have enough data to decide where to go. Make it open first and then extend it. And small things are simple. That's what we want. And finally, you have to trust. You have to trust the principles of object-oriented design. You have to have faith in refactoring. And the intermediate steps are almost always more complicated, but in the end, it always comes out simpler. And so what we want, if you do this, if you trust the refactorings, you can end up with simple, straightforward, understandable, and extensible code. And so there you go. Thank you. Perfect. Okay. I have one more thing. So I told you that Jim Wyrick pointed me to this kata back in November, and I didn't look at it for a while, and then I finally messed with it. And it was New Year's or so when I started working on the refactorings. And so I decided to do this talk based on it. And I made, I sat down and did like 1 million slides of code, which you've seen. And I'd gotten to the point a couple weeks ago where it was time to start making it funny, start adding levity. So I was sitting at my PC, sitting at my laptop, making up jokes on the day Jim died. And so I deleted all the jokes, and I quit thinking about what bicycle-related T-shirt I was going to wear for this talk. And I realized that the Gilded Rose had one final lesson for me, and it was that while it can never be too early to say thanks, it can sometimes be too late. And so I know my timing is abysmal, but even so, if you have a glass, please raise it with me. I'd like a toast. My deepest thanks to Jim.